USACO 2014 December bronze number 3 cold jog. Let's get into it. The cows are out exercise their herbs again. There are n cows, 1 to the 100,000, jogging on an infinity long single lane track. Each cow starts at a distinct position on the track, and some cows jog at different speeds. With only one lane in a track, cows cannot pass each other. When a faster cow catches up to another cow, she has to slow down to avoid running into the other cow, becoming part of the same running group. Eventually, no more cows will run into each other. Farmer John wonders how many groups will be left when this happens. Please help him compute this number. Okay, let's check input value. Input value is cowjog.in. This is sample input. Okay, the following n line each the first 9 number input contain the integer n. This means there are 5 cows. The following n lines each contain the initial position and speed of a single cow. So in this case, the first cow position is 0, second is 1, third is 2, first is 3, fifth is 6, and this one indicated a speed of cow. Okay, so first we're gonna make code to read this info file, and then we're gonna use import sys, and sys standard input, and we're gonna open the file. Name is cowjog.in and read mode. And then we're gonna skip the first line because we can easy to calculate only the length of this data. So get rid of first one, and then we're gonna make one list to put it for a line in system standard in, and this is first line, and then this one is string, so we're gonna split, and then it changes to the to string, and then we convert it to integer with a math function, and then we're gonna wrap it with a list. So cows offense and list wrapping, and the map integer and line split. Then maybe we can get data what we want. List. Oh, interesting. Map into split. Typo. So we got this one, right? So we're gonna put this one as input. This is same. So we are gonna make function using this one. Name is cowjog, and finish cowjog, and we're gonna have cows. Okay, then let's check with the example. So this is the first cow. The index is 0, and this is 1, 2, 3, 4. So a first cow located in here, right? And then second is 1, and third is 2, 3, 4. So this is the initial state, and then next turn this one speed is 1, right? So this one will going to here. And then the same way, the one index call go to the 2. So it go to 2, and then 2. 2 will be go to 3. And in this case, 3 is means 2 plus 3 is 5. And then this one is the same position of 3. So you're gonna make one group. So in this case, the cow index 2 is observed by the 3. So now the group is 3. The same way, this one is 3, and then now 3, and then finally there are only 2 groups. So we're gonna return 2. Does this make sense? What should I do? First, we're gonna start with the solution. And then this is cow. We're gonna do I and j. And then 2. And then we're gonna calculate the count, group count. Now its group is 0. And then we're gonna check one by one with speed. So if speed is slower than this one, maybe it will be a catch. But in this case, this one is faster, so this group cannot catch this one, and 3 cannot catch because this is faster. Faster. How about same? Same speed also could not catch up because there are distance do not reduce. So in this case, this one cannot catch anything. So this one is the independent group. So we able to increase it. Does this make sense? And then let's check the second one. 2, 3, this one is fast. Same, slow. So this one able to catch this one, right? So we do not count group because this one will be observed by cow index 4. How about this? This one is same, right? This is faster than 1. This one is same. How about this? In this case, this one will be independent group because this is final. So finally, we're gonna return true. 2. Does this make sense? In this case, we're gonna use 2 iteration, loop in loop. So time complexity is equal n squared, and space is constant because we do not use any data structure. Okay, let's implement this code. So first, n is the length of calls, and then we need count. Let's say that is group. Count is better. So first is I in range length of m. And the second j is range I plus 1. So I start with here, right? J is next of I. In this case, no need to check this part, right? Because only check the right side. So if cow's I's speed is smaller than cow's faster than cow's JN1, in this case we're gonna break because no need to increase the counter. As means there are no the cow the faster than I. No, there are no cow slower than I. So that means in this case we find slower. This is fast, same, slower. Then this one do not count. In this case, this one going to break. Otherwise, we're gonna increase count. And then finally we're gonna return it, check it. So we're gonna value. Okay, now let's make it better. This one will work, but it meet the timeout because this is n-square solution. We need to find the better approach. How could we do? What if we check from the last? So this is last. And then in this case, this one must be group because this is last, right? And then we can save the speed. Speed is currently 1 because this is speed 1, right? And then we're gonna check, is there any cow equal smaller than last one? Otherwise, it will observed by last cow. So in this case, 2 is the bigger than 1, right? And then it will be observed grouped by this one because this is slow. And then how about 3? This is also same because this is faster than 1. How about this? This one also faster. But this one is not faster, same. So it will be different group. So we're gonna check. First, maybe we're gonna do infinity. And then gonna check this one. If this one is small equal than this one, we're gonna update this one and then find one by one. At this time, we just use one iteration. So time complexity is it must be checked from last. And this one if we go n and space is 1. Okay, let's make cow jump and cows. N is the length of cows and speed is we're gonna initialize with infinity and then count must be 0. So for I in range n minus 1 because we're gonna check from last and it's 1 minus 1. And then if cow size speed is smaller equal than speed, we're gonna update the speed. Current 1 and then increase counter. Finally, we're gonna return count. And then let's run. This one is 2. Okay. Standard out, often, cow jump out, and then this is right move. Okay, looks good. And then let's check. Submit. Thank you.